Okay, let's have a look at homework number 7. So the first question was number 2 from the book. Uh, Find a proof similar to the first case in the case of the second figure of Euclid 2.5. So here we got Euclid 2.5 here, and that's the situation where we have got AE, and we split it in half at W, and W lies between B and E. Okay, so we do that. So half AE is the same thing as AW, it's the same thing as GL, FK, LK, GF, LM, and WE. And X is going to be GD. It's going to be this little side of the square here, GD and GA. So the square on AW is that square GLKF there, and that's equal to the square on BW plus this nomen that we have here, GLWBHF. Now that nomen is equal to the rectangle GD FH, so this rectangle here, plus this little rectangle here, DLWB. Now that rectangle GDFH is x by half AE, so it's the same thing as that rectangle LMEW. So hence the nomen is equal to the rectangle DLWB plus the rectangle LMEW. So add them together, we get DBEM, which is AB times BE. Hence the square on AW is the same as the rectangle AB times BE plus the square in BW. So if we take the example of mal and 21 equals 10 roots, so that means AB times B equals 21 and A equals 10. So half of 10 is 5, that's AW. So we have the square on AW, which is 25, equals 21 plus that square on BW, which is 5 minus x squared. So that means 4 equals 5 minus x squared, 2 equals 5 minus x. So x equals 3. Okay, so number 2 was number 4 in the book, to show that square root of A plus square root of B equals square root of A plus B plus 2 square root of AB. And you just draw the square like that. So if the squares are A and B, then the sides of the square are square root of A and square root of B, and then you just add up all the squares. There was a problem, so I didn't end up grading this question because there was a problem in the textbook. It should have been show square root of A minus square root of B is equal to square root of A plus B minus 2 square root of AB. And so there was just a typo in that. Okay, number 3 was give a geometric solution to x squared equals 10x plus 24 using Euclid 2.6 where appropriate. So the picture you would get would be something like this. So you'd have the big whole square is x, and then one here you have 10. So this area of this rectangle is 10x, and the area of this rectangle is 24. And so by using Euclid 2.6, this square here, A, B, C, D, is going to equal 25 plus 24. And so what's going to happen is that x equals 5 plus square root of 49. So it's going to equal 5 plus that is a square is 49 there. So that's 5 plus square root of 49 is 12.